In the early 1800s, the rapidly growing city of London found the method of disposing with its waste no longer viable. Disease was rife, and the health of the city was deteriorating. As part of the huge project to address the epidemic, Sir Joseph Bazalgette introduced his interceptor system, which stemmed the direct sewage flow into the Thames that had come from three main rivers since the Middle Ages. One of those three rivers, the Tyburn, which had delivered waste into the Thames at Westminster, became the King's Scholar Pond combined sewer overflow. This ancient infrastructure tunnel is still a functional drain and part of the Thames Water network. Part of the King's Scholar Pond runs directly over Baker Street Underground Station and had been strengthened over the years, but the time has come for a solution that will last for the future. The project is particularly challenging as it sits right in the middle of a critical section of London's traffic and travel network.
The existing structure at the moment has had a number of different types of repair and remedial work carried out to it over its lifespan. Originally it started off as a sewer. It was then changed when the London Underground tunnels were put in. Those tunnels then changed the bottom half of that sewer into a cast iron, the side plates, invert plate and cast iron girders. It was then subsequently bomb-proofed on top during World War II, and they put a series of reinforced girders and concrete and shingle. And then on top of that, during the London Olympics, they put a series of ribs on the inside to help strengthen the structure. So we've kind of had to look at a solution where we've gone, how can we build it from the inside out?
This is the junction of Marylebone Road and Baker Street, two of the busiest streets in London. We obviously couldn't close either road. Below us is the Circle Line, one of the busiest tubes in London. Our solution is to modularise the entire structure and build it in situ. The entire modular structure has to fit through a 600mm by 750mm manhole.
The asset is quite challenging, being made out of cast iron. Naturally, this means that you can't actually do much to it, so we've had to look away from using the existing structure as much as possible. The solution is a duplex stainless steel Virendeel truss with an associated glass reinforced fibre liner going through the middle of it. The idea is that this cage will go in and span the width of the London Underground tunnel below, being supported on its existing foundations, effectively forming a bridge. That bridge will then carry water load from one side to the other, taking the risk out of the existing asset.
In terms of the actual construction sequence, what we're doing is installing the truss, each side of it as an individual piece, lifting it over to the side of the sewer, installing the next one, lifting it over. We'd have pre-installed roof arches and installed them into the roof of the sewer. These are being brought down, and then the invert straps and invert beams are installed then afterwards. This allows us to remove the temporary works that's already pre-existing in the sewer. Then we install the bracing, and then finally the GRP.
Health and safety is particularly important to us on a site like this. Given that we're working in a live sewer, we've had to take reasonable measures to ensure we can maintain a safe system of work. What we've done is we've got a series of flow gauges upstream monitoring the flow as it comes in, which enables us to know when the flow is coming into the sewer so we can get out in time. In addition to this, we've got a series of cameras that will also be placed inside the sewer to monitor flows upstream and on the work site, so the confined space manager can monitor both sides and make sure that the people inside are kept safe.
Two of the biggest risks we have, the confined space, and that's obviously the gas and so involved with sewers, but obviously the water itself. And of course, some of that steel is 136 kilos. The truss itself is 2 tonne. We do not take risks here. Everything is taken to the nth degree with safety.
The design life of our project is 120 years, which has meant we really had to look at how we can future-proof this design. We've also got a number of pipe bridges across the network that are very similar, that in the future may need remedial work. So what we will be looking to do is create this as a template and then possibly employ that later in the future.
It is so innovative, you know, like I'd be very lucky if I ever work on a similar site again, to be fair, or a site of this complexity again, and yeah, that's something I'm definitely very proud of.
It's been a fantastic project to work on. We've had some brilliant minds working on it, a great site team, and I'm really looking forward to how this project moves in the future.